Hi, in this lesson, we'll be finding the zeros of the third degree polynomial. I will use these two examples, example 1 for solving for p of x and also example 2 for q of x. I will use these two examples to illustrate how to find the zeros of a third degree polynomial. We'll be using two methods. We'll use the grouping method, and also we'll substitute for rational zeros of this polynomial. Let's get started with the grouping method with example 1. Now, in example 1, we have that p of x is equals to x raised to power 3 minus 4x squared minus 9x plus 36. Obviously, from this example, I can easily group them. You see that x raised to power 3 and 4 of x have something in common, which is x squared. X9 minus 9x and 36 have something in common, which is minus 9x. Now let's see. We can regroup it to become x squared. You now have x minus 4. Now between minus 9 and 36, it becomes minus 9 into x minus 4. Remember that minus 9 times minus 4 will give us plus 36. Now I can now conclude this to become x squared minus 9 equals x into x minus 4. So that we have x squared minus 9. We can further break down x squared minus 9. We can further break down x squared minus 9 into difference with difference of 2 square. You know that if you further break it down, that will be x minus 3 into x plus 3. We'll attach in the description our lessons where we taught completing the square, quadratic equations, and we treated difference of 2 square. Now into x minus 4. Now these are definitely the factors. Now we can conclude that the zeros of this polynomial are x minus 3 is equals to 0, so that x now will be equals to 3. X plus 3 is equals to 0, so that x will be equals to minus 3, and x minus 4 is equals to 0, so that x will be equals to 4. Thank you. And now let's see the second question. Now for the second question, you observe that q of x is equals to x raised to power 3 plus 4x squared plus 5x plus 2. Now if q of x is equals to x raised to power 3, and you observe this quickly, you see that we cannot group this question. We cannot group this. Now what we're going to do is we're going to look for the zeros of this polynomial simply by looking for rational zeros. Now to look for rational zeros, pick the highest term here, which is x raised to power 3, and pick the lowest term here, that's x raised to power 0. Now this is as good as this is 2, as good as I have x raised to power 0 here. That's the lowest term. Now I'm going to pick this, and the term here I have 2 and here I have 1. So I'll be picking 2 divided by 1, which is equals to 2. So the factors or the zeros I'll be looking at are factors of this 2, which is 1 plus or minus 1 and plus or minus 2. Now let's look for it. Now this is what I'll do. Just pick this. The question is x. For the coefficient of x here is 1. I have 1 here. The coefficient of 4 here is, the coefficient of 4 here, of x squared is plus 4. I have plus 4. The coefficient of x there is plus 5. And the last coefficient of x raised to power 0 is plus 2. Now, one of the zeros I am suspecting for this polynomial is plus 1. Let's start with plus 1. I have plus 1 out here. Now I'm going to bring this 1, this particular one, just write it down here, that is 1. 1 times 1 here is 1. 1 plus 4, that is 5. This 1 times 5, that's 5. 5 plus 5, that's 10. Now, 5 times 5, that's 10. 1 times 10 now, that's 10. 10 plus 2, that's 12. Because I did not get a 0 here, definitely this is not a 0 of this polynomial. Now, let's try minus 1. Now, for minus 1 here, I'll have this again. Here's minus 1. The factors, the coefficients, I have 1, I have plus 4, I have plus 5, and I have plus 2. Now, bring down this 1 again. 1 times minus 1 times 1, that's minus 1. Plus 4 minus 1, that's plus 3. Minus 1 times 3, that's minus 3. Minus 5 plus 5 minus 3, that's plus 2. Minus 1 times plus 2, that's minus 2. Plus 2 and minus 2. Obviously, the answer is 0. Now, since I'm having 0 at the last point here, minus 1 is a 0 of this polynomial. That is, x is equals to minus 1. So, if x is equals to 0, minus 1, that means x plus 1 is equals to 0, making x plus 1 a factor of this particular polynomial. Now, we still have 2, we have plus and minus 2 left to try. Now, let's try for plus and minus 2. I will want to remind you that the first 0 we got for this polynomial was minus 1. So that x plus 1 is a factor for this polynomial. Now, we're going to try x is equals to plus 2. Now, for here, let's have it this way once again. I have the coefficients 1, plus 4, plus 5, and plus 2. Now, I have plus 2 here. Plus 2 times, I have 1 as we did, plus 2 times 1, that's plus 2. Plus 4 plus 2, that's plus 6. Plus 2 times 6, that's plus 12. Plus 5 plus 12, that's plus 17. Now, plus 2 times 17, that's plus 34. Plus 2 plus 34, that's plus 36. Obviously, this is not a 0 for this polynomial. Now, let's try the last one, and that is minus 2. Definitely minus 2 is a 0 for this polynomial. But let's give it a try first. 1, I have plus 4, we have plus 5, and we have plus 2. Now, minus 2 here, I have 1. Let's bring 1 down. Minus 2 times plus 1, that's minus 2. Plus 4 minus 2, that's plus 2. Minus 2 times plus 2, that's minus 4. Plus 5 minus 4, that's plus 1. Minus 2 times plus 1, that's minus 2. Plus 2 minus 2, that is 0. So because I'm getting 0 here, obviously this is another 0 for that polynomial. And we can say that x now is equals to minus 2. So that x plus 2 is equals to 0. So that x plus 2 is a factor of this polynomial. Now, I have gotten two factors. I have x plus 2 and I have x plus 1. Now, look at this carefully. Because for this polynomial, I have x plus 2 and x plus 1. Then I have this raised to power 3. X is raised to power 3. So the zeros of this polynomial must be 3. And they must be, that means one of these, x plus 2 or x plus 1, is repeated. But I know if you multiply them out and multiply them repeatedly, you see that x plus 1 is repeated twice. So we have x plus 1 into x plus 1 and x plus 1 into x plus 2. So these are the factors of this polynomial. Thank you. See you in our next class.